Hello there, everybody. This is Chapter 7. We're going to start. This is going to be in combination with Chapter 6. So 6 and 7 are on one test and one quiz. And they're very related. So far what we've done is factor, 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 right? We've done a ton of it. And we kind of saw with our rational expressions why we would need it. Then we saw why we would need it for solving equations. And now what we're going to do is we're going to keep going with that thought. We're going to reduce down our fractions using our factoring techniques. And the first thing that we're going to do is talk about the domain again, which you can see on our homework. That's where we start. And I can kind of show you later why we would need the domain. All right, so again, I've told you that this is a very difficult concept for most people to grasp. So they just keep hitting it with wherever they can. So here's another spot that they're hitting it. So we have to do some review work just because it's been a while since we've talked about the domain. And especially confusing when they give you your function in terms of y. Well, I don't understand why they do that. It just drives me crazy, but just pretend for this sake that they're x's. Okay, so just pretend that it's a function in x because that's a normal function. If it was like this, the domain is what can or can't x be. Remember, it's a lot easier to say what it can't be because usually it's, right, like on this one, the only thing that x can't be is 4. It can be anything else. So it's a lot easier to say what it can't be than listing what everything it can be. So the two things that we're looking for are negative square roots. Remember that? All right, I don't have any roots on this one, so I don't have to worry about that. And the other one is division by 0. Okay, I do have division. So I have to take the denominator and set it equal to 0 and say that it can't be equal to 0. Okay, this piece down here can't be 0. Remember, anything divided by 0 gives you that error message on here. So 8 divided by 0 says just quit. I hate that message. Just quit. It's very discouraging. But it's undefined. It should say undefined. So we solve for x by adding our 4 across. It's a very negative attitude on the calculator's part. Just quit. X cannot be 4. Okay, that's the only thing that I can put in this bottom that'll make the bottom of 0. And I don't care about the numerator at all. Numerator can be whatever it wants to be. It can be 0. It can be anything. So we do have some excluded values on this one. The numbers that are excluded would be 4. Okay, so you're just going to put that in there. Now, remember what set notation is. Set notation was that fancy formal language. The set of all x such that x cannot be 4. Okay? The set of all x such that x cannot be 4. Meaning all real numbers except 4. Now remember, the domain was restricted to real numbers. It can't include imaginaries, and that's why we have this negative square root thing. Okay? For our problem, since we have y's, it would be the set of all y such that y cannot be 4. And the only reason that I did x's over here is because usually we define the domain as what can or can't x be, and the range as what can or can't y be. And then, I could use the word input, output, because then it doesn't matter on the letters, which I probably should have done. It's a little bit more clear. The domain of the function in set notation is the set of all y such that y cannot be not equal to 4. So that's your formal way of writing y can't be 4. Okay? So you're going to get, on these, you're going to get this is one part remaining. There's two pieces to it. First of all, you just list the number or numbers, and then you write it in set notation. So again, here I don't care about the numerator, I just care about the denominator. The denominator, 2y plus 5, cannot be 0, right? Numerator can be anything. So what I'm doing here is I'm solving for y. Solving for the input. Cannot be negative 5. Divide through by 2, so y cannot be negative 5 halves. Okay, so that's what you would put in here, and then you would write in set notation from there. And these are all done the same. All right, again, I only am concerned about the denominator. Well, what makes it equal to 0 or not equal to 0? You can do it either way. Well, remember when I had an expression that was equal to 0 and I had to factor so that I could break it apart and use my a times b is equal to 0 principle? I'm going to do the same thing here. I look at that expression, and that's one of those easy trinomials. It's got the x squared x no x pattern. My variable here happens to be a z. I've got a negative here, so that's one of each. My factors of 18, let's list them over here. We've got 1 times 18, we've got 2 times 9, and we've got 3 times 6. Since this is a negative, I have to subtract to a 3. That's this pair right here. Since my negative is on, I have a negative middle term, I'm going to put the bigger number with the negative and the smaller number with the positive. Okay, I'm going to refoil to make sure that I've done it correctly. Now I can say either this cannot be 0 or this cannot be 0. So again, I'm solving for the variable. So z cannot be negative 3. I would subtract my 3 across, or here I would add my 6 across. And z can't be 6. So those are my two restrictions. If I would put these in to this expression, I get exactly 0 out of them. Okay? Now remember, you can check them with a calculator, you can graph them, you can do whatever you want to do, but on a test situation, make sure that you're checking things before you're submitting, because you can always go back and change your answers prior to that. So I hope that's what you're doing. All right. And then you would convert that over to set notation. What about this one? All I care about is the denominator. Okay. Is there any way that I could ever get that 2 to turn into a 0? Well, no, there's no variable down there. So it's just always a 2. So in that case, there are no excluded values. Okay, I can never get that to be a 0. I still don't have any roots, square roots or anything like that. So in translation, that means that the domain is a set of all real numbers. That means I can put anything I want in there and I won't get that message, that error message on my calculator. Okay? All right, here we go. Write the rational expression in lowest terms. Well, what is a rational expression? And a rational expression is just a fancy way of saying a fraction, if you want to look at it that way. That's what rational means. It's a ratio of things, so it's fractional. And instead of having a fraction like this, I've got variables, I've got pluses and minuses, I've got expressions. Okay? So the thing that you need to know about rational expressions is that you can't, what am I trying to say here? You can't cancel like this. This is one of the biggest things that I see. Oh, I see an x and an x here, so I'm just going to cancel these off. So my answer would be 4 divided by 2, or 2. Well, let's just put an answer in there, or a number for x. Let's just put a 3 in there and see if it turns out to be 2, because if it does, then that was a valid thing to do. But this actually ends up to be 7/5, which is definitely not 2. So this is not valid. You can't do that, okay? And to remind ourselves that we can't do that, we are going to put parentheses around everything and say that we can never go on the inside of those parentheses and start doing this. In order to cancel, they have to match exactly. I mean, look at this y minus 1 and this y minus 1. They match exactly. One's on top and one's on the bottom, so those can get canceled. So when I write this like this, as long as I have the entire set canceling with the entire set, I'm good to go. This y is on the inside as well as that one, so I have to leave those alone. Okay? There's my final answer. Done. All right, let's take a look at this one. We're just simplifying fractions that have a lot going on. They're messy. All right. All right. To remind myself, I can always put parentheses around each factor, each piece that's by itself, just so that I don't want to go on the inside of those. So I've got a 32, I've got a p squared, I've got a p minus 9. If that helps you, please do so, at least in the beginning. Now, do these match? No, they're opposite signs, so nothing can be done with these. But I can isolate this piece of it right here and say a p divided by a p squared will give me 1p on the bottom, correct? Right? I have 1 on top, 2 on the bottom, that leaves me with 1 on the bottom. So I can't do anything with this p plus 9, and I can't do anything with the p minus 9, but I can reduce 4 32nds. 4 32nds is the same as 1/8, and this 1 is not needed, so it's just p plus 9 over 8p p minus 9. Now make sure that you put this in parentheses, this piece right here. If you don't, it's going to be incorrect, okay? So should we check that one? I'm not going to check them all. Why? Because I'm darn lazy. I'm going to check the ones that are different maybe, or that you haven't seen how to enter them in, but you know, what I did was I first of all clicked on the fraction button and then just started filling in the boxes. Okay? You've got 20 points here, so there's a lot of them in here. All right. What about this one? Well, nothing matches. So you would almost think, oh, great, I'm done. But you're not. So what we want to do is we want to turn this addition subtraction into multiplication. And how do I do that? That looks like a 9. That's a 4. How do I do that? I factor, right? Factoring turns addition subtraction into multiplication. So I'm going to go down here and say, okay, what can I do to this problem here? Well, I know that it's not a difference of squares and it doesn't have enough terms to be the trinomials or the groupings, so it's got to be a GCF, and I do see a common 8 in here. Okay? So I would see what's left. 8's are gone, so I have x minus 5, right? Negative 40 divided by 8 is negative 5. So that's what that is factored. Do you see how I've broken it down into multiplication? I'm going to do the same thing with this one. 7x minus 35. Again, I'm seeing a common 7 in there. Divide both pieces by 7. We have x minus 5, right? Negative 35 divided by 7 is your negative 5. So I'll put this here. Okay? Now I'm going to cancel. I see x minus 5s are common, and an 8/7 is not reducible, so I'm finished. So I've got 8/7 for my answer. Same thing here. You're going to want to factor, factor, factor. What kind of a factoring problem do you have on the top? Looks like a GCF to me. What about the bottom? Difference of squares. Break it apart into its component pieces and cancel what you can. Okay? I'm not going to do all of these. Same thing here. We have a trinomial and a trinomial. All right. I cannot cancel these, right? I cannot cancel these. I have to break them down into their component pieces, into a binomial times a binomial, and I do that through factoring. Okay, should I just do that one real quick? Okay, quit nagging. I'm smiling right now, but you can't see that. All right, we know that this is an x, same signs, both negative. Two numbers that multiply to 2 and add to 3, 2 and 1. X's are my variable. I've got a subtraction, one of each. Two numbers that multiply to 10, subtract to 3. It's a 5 times 2, right? That's my combo. I've got a positive 3, so I'm going to put the 5 here, and I'm going to put the 2 there. Now I cancel. I see this is gone. What's left? X minus 1 on the top, and x plus 5 on the bottom. Done. You are not going to cancel those, right? Because they do have parentheses around them, even though we don't need to put them in on MyMathLab. So don't put them in. I don't know if it's going to kick it out or not. Too lazy to check. Same thing here. AC method, AC method. You're going to break it down into 2 pieces, and then 2 pieces, and then cancel what you can. Okay? What about this one? I have to drag that down so we can see it all. 4 terms, nothing in common. 4 terms and nothing in common. Well, that's grouping. So group, 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 right? Find out what's left as far as your binomials and cancel. So far we haven't done a whole lot. Well, maybe. I'm wondering if that one is different. That one might be just a little different. Am I already at the bottom? Holy moly. All right. It's a good thing I didn't swear there. It's happened before. All right. Well, because we can and we have time, let's just do it. Because there's one type in here. Can I just look? It's okay. It's this one. And then I'll go back to number 11 because I'm going to do it on an easier one first. All right. Upon inspection, I can see that these are not the same. I've got a positive 8 and a negative w. Here I have a positive w and a negative 8. Right? They're not the same, so I can't just cross them off. I can't do anything with factoring, right? Nothing's common. They're not difference of squares or trinomials or anything like that. So on first inspection, you would say that there's nothing that you can't do anything with this. But remember, there's always a 1 and a negative 1 in every single expression. All right? So if I take out my negative 1, all right, I had to pause that thing. My dog was whining at the window at me. I don't know what his problem is lately, but he's really lonely. Okay, so where were we? Okay, so in any expression, there's always a negative 1 and a positive 1 that's in there. I can always say that, all right? So let's divide through each term by that GCF of a negative 1. This becomes a negative w, and this becomes a positive 8. Now remember, addition is commutative. So if I wanted to, I could flip-flop these around, right? Just retain my signs. I have a positive 8 and I have a negative w. So you really can see that they're the same thing now. Now I can cancel them. And what's left? A 1 divided by negative 1, which is negative 1. Okay? So that's all that's left there. Negative 1. Let's try it. Okay? So sometimes, even though it looks like you can't do anything, you might have to take that negative 1 out. So let's go back to this one, which I think, see how these are opposite signs? You got a negative 2 and a positive 2 and a positive 2 and a negative 2. This might be one of those ones. So let's, and then when everything doesn't go away, then it's harder to, then you have all these different ways that you can write it. So that's why I want to show you, especially on a multiple choice. All right. 4 terms, nothing in common, grouping. Okay, so let's just work on that front one first, the top one, the numerator. I'll do these one at a time. All right, so I'm going to get a binomial times a binomial and a binomial times a binomial. So I'm going to do this piece of it when I'm done with my work down here. So take your numerator off to the side and group front 2 and back 2. All right, what do I have here? I have a common y, right? I don't know if this is one of those ones that need to be changed or not. It just kind of looked like one, but maybe not. So then we have k minus n, right? K and n are left over. There's a subtraction between them. And here I'm going to pull out a -2 because I want this front piece, this k, to be positive because that one's positive. So if I take out a -2, let's see what happens. -2, -2. This becomes a 1. Okay, so we pulled the -2 out of there, so that becomes a positive k. And then this becomes a -1, right? 2 divided by -2, so that becomes a -n. See, what I'm trying to do is I'm trying to force these to be the same. So I took out the negative rather than the positive. I know we saw those before. So now our 4 terms went to 3 terms to 2 terms. These 2 terms have the k minus n in common. What's left over is the y minus 2. It's a good review anyway. So that's your top piece broken apart. Now we're going to have to do it again down here, right? So let's get some room. We'll go back up there when we're done with it. Yk, y minus yn plus 2k minus 2n, group, right? That has a common y with it. So I have k minus n left over. This has a common 2. This time I want to pull out the positive 2 because I want this front one to be positive like that one. 2 and 2. So we have k minus n left over. Good thing, these need to match. Between those two we have a k minus n that's in common, and we have a y plus 2 left over, the outside pieces. This piece of it, this factoring piece of it, should be all just super review for you. So k minus n, y plus 2. Okay. These match perfectly, they're gone. These do not. But even if I were to do that negative thing, it wouldn't match still. Because if I took a -1 out of this thing, then it would become a -y and a -2. The 2 changed to be the same, but now my y's are off. So I can never do anything with one of those. They would both have to be off in order for you to change it. Okay? Do you see how the difference between this one and number 13? Here my y's are the same, my 2's are not, so I'm done. So my answer is just y minus 2 over y plus 2. But look at number 12, not 13, 12. They were both different. Positive, negative, negative, positive. Then that method works. Okay? So that's the difference between fixing this one and fixing that one. This one can't be fixed and that one can be, or reduced. All right. So you can see here that these two can never be the same. You can't force those to be the same because the x's are the same and the 2's are the opposite. So these two you can't mess with. But this one I know you can. This one you've got a positive a and a -6, positive 6 and a negative a. All right? So let's try that one. Where am I here? All right, so now the key here is that you don't want to change more than one thing. All right, you want to just do one piece of it. Doesn't matter if you do the top or the bottom, makes no difference whatsoever, so I'm just going to randomly pick the top. I'm going to randomly choose to divide through by -1, so that makes that a negative a and a positive 6. And I'm going to leave everything else alone. I don't want to mess with too much there. Okay, now are these the same? Negative a, positive 6, positive 6, absolutely. Okay, so what we have left is x plus 2 over x minus 2. Now this is a fairly complicated idea, but this -1 is a floater. Okay, I can do one of three things really with it. I can leave it alone like it, well actually there's more than that. I can either leave it alone like that, or I can say it's equal to, and I can throw it in on the bottom. Those are exactly the same. Or I could throw it out front. Or I could take the -1 off of it and just do a negative and throw it out front. Or I could choose to distribute this through the top. Or I could choose to distribute it through the bottom. Too many choices. All of these are identical. So a negative somewhere multiplied it's a floater, and you can put it wherever you'd like. So when you've been given multiple choice like this, you have to kind of play around with the choices and see, okay, which one do I really have? My initial was this, and that's not that. That's that without that -1, so it can't be that one. So here is a choice. We've got the x plus 2x minus 2. That's this one right here, right? They've chosen to do this one. Let's see what else. So that one looks really good. Well, a -1, no, we can't cancel these two, right? At any point we can't cancel these because the signs are off just for 1. And obviously it's not already in lowest terms. We can do something with it. So it's got to be B. It's got to be B. It's usually always C. Whenever I have multiple choice on a preview for homework, it's always a C. So that's kind of nice and refreshing to have a B all of a sudden. I don't know why that is. All right. Should we do this? This one's actually really easy. Okay. Multiplication. I can get rid of the multiplication sign and I can just squish everything on one line. And same thing here. I can rearrange the order if I want. I can do anything I want with this thing. But that's equivalent to two separate ones with a dot between them. And now I'm just canceling entire sets with entire sets with entire sets, right? All that's left is this on top and that underneath, and you will not cancel your y's out. You're done. This is the answer. You will not. All right, how do I divide fractions? Do you remember? 1/2 divided by 3/7 is the same as 1/2 times 7/3. I keep the first fraction alone. I change my division to multiplication and I invert. And I multiply. So here, I keep this first fraction the way it is. And now I'm going to just flip this upside down. So I'm going to put these two on the top, y minus 3, y plus 5, and I'm going to put these two underneath, y minus 3, y minus 1. Now I'm going to start canceling. I've got these two to get rid of, these two to get rid of, these two to get rid of, and I'm left with that over that. Done. So even though I gave you 20 problems, they're pretty simple. You're not canceling your y's. Some of these are really easy. All right. So now what do we do? Well, looks to me like nothing's the same, so I'm done. But am I? No, I need a new screen. Okay. What we're going to do is we're going to factor so that we have products. We're going to see if the products match so that we can cancel. Okay? So we have 2z over 6z plus 2. Okay, so I'm going to do this. And then I have the 27z plus 9 and a 5. All right, so I'm going to analyze what can I change, what can't I change. Well, a 2 and a z and a 5 are all prime. There's nothing I can do with those, so I'm just going to keep those the way they are. Now, 6z plus 2 has a GCF of a 2 in it, right? So if I divide through by 2, I've got 3 z's plus 1. That's 1. So I can do my 2 and then my 3z plus 1. I'm going to do the same thing here. 27z plus 9 has a common 9 in it. I'm going to divide both of these by 9. Can I get that in there? Yep. 3z plus 1. That goes on top. There you go. Now I've got everything into products. I have no more addition subtraction between my parentheses. Now I cancel. My 2's can go. My 3z plus 1's can go. What's left? A 9z on top and a 5 underneath. Done. Should we try that one? What is it? 9z over 5. 9z divided by 5. Good job. Same thing here. You've got multiplication. Factor, 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 factor. Each one has a GCF in it. Take the GCF out and see what's left. Okay? So the common 10, this has a common 5, this has a common 7, and this has a common 14? Is 42 divided by, yeah, it should be. Yep. 3 times. Okay? And then you can always work with your numbers separately, too. Maybe we should do this one. I'm worried about the numbers, if those will appear to be difficult. If you're not having trouble with that kind of stuff, then just fast forward this till you see a new problem. Plus, I don't know how many of these I'm going to be doing either. I mean, if they're all done the same, then... All right, there's a common 5. I divide this by 5 and this by 5, gives me x minus 3. I'm just going to go through this pretty fast because this piece of it should be really well known by now. Common 10. If I divide through by 10, I get x plus 3, right? Common 7. Divide through by 7, I get x plus 3. Common 14. And I would have a x minus 3 left over. So my x plus 3, those are gone. My x minus 3, those are gone. All that's left are numbers. So I have 5 times 10 over 7 times 14. Well, let's see if we can't. It's going to want the fraction. It doesn't want this thing. So if I have 5 times 10, and I want that whole thing in parentheses to be divided by another set of parentheses, 7 times 14, I get 25/49. Done. Okay? Good job. Same thing here. I'm not going to do this one for you. Trinomial, 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 trinomial. Factor it 4 times. Cancel what you can. Okay, those are all easy trinomials. These are all difficult trinomials. These are all AAC method trinomials. Now you've got a division here. So you're going to factor all 4 of them, but you're going to invert these 2. You're going to flip these 2 upside down and then cancel. Okay, so you've got a lot of work in here. You've got 4 different AC methods to work out. So that's all. That is not the best problem, but at least they're small. You know, you've got 16, 16, 4, and 16. So those aren't too bad. Of course, yours is not my problem, but you'll have a different problem. It should be about the same. Yikes. Should we do that one? Yeah, I think we should. And then I'll be done. All right, I have, what do I have? What do I have? What do I have? I have 12k squared minus 5k minus 2. And I'm going to divide that by k squared plus 9k. All right, I'm going to, okay, so what I want to do is, I've got this big set of parentheses here, so I'm just going to work within this set of parentheses, right in through here. I'm not going to mess with this one yet. Pretend like it's not there. Just work with these two. I want to multiply by the reciprocal of this. K cubed plus 6k squared minus 27k over 3k minus 2. Okay? These are all pieces. All right, so I've got an AC method here, right? I've got a GCF there. I've got a GCF which will turn into a trinomial here, and I've got prime. So let's work on this to see what we can do with that. Let's go down to the bottom here. So I've got some room up there, and I'll put it back up that way. But we have the 12k squared minus 5k minus 2. Okay, so we're using the AC method. A times C is 24. And I need one combination that multiplies to 24, and we want to subtract to the 5 because that's the negative. So just for time's sake, I know it's that one. It's an 8 and a 3, right? I mean, I could list them all, but if I can see it, I'm just going to do that. So now I'm going to rewrite. I need a negative 8, a negative 5, so I put the negative 8 here, positive 3 there, and then I group. The front two, what do they have in common? They have a 4 and a k in common. If I divide 3 by 4k, I'm left with 3k minus 2. What do these have in common? Nothing. They always have a 1 in common though. So I've got my 3k minus 2. Remember, whenever I do my factor by grouping, I want these two parentheses to match, but I got to have something here. Okay? Otherwise it's not going to look right. So I can always multiply by 1. That's always valid. So this is equal to, we've got the 3k minus 2 in common, that's these two, and the outside pieces are what's left, 4k plus 1. So that's what I'm going to put up there, 3k minus 2, if I can remember. Where am I? Three k minus 2, well, what was, of course I can't remember, 4k plus 1. 4k plus 1. Okay, that one's prime. I'm just going to stack it here because it doesn't matter where I put these. This one here has a common k in it. So if I divide the k out of there, I end up with k plus 9, right? So here I've got a k and a k plus 9. Now I got to work on this thing. Okay, so I'm going to go down to the bottom again. Boy, this is going to be a long problem. Holy moly. All right, so I have k cubed plus 6k squared minus 27k. Well, the first thing that I see is there's a common k, so I'm going to get that out of there. If I divide each one of these by k, I'm left with k squared plus 6k minus 27, which turns into one of those factorable trinomials. Don't forget that. I have a k for my variable. I've got a negative here, so that's 1 plus 1 minus. And I'm taking two numbers that multiply to 27 and subtract to 6. So that would be the 3 times 9, right? I want a positive 6, so I'm going to put the 9 here and the 3 here. So that's what goes there. K plus 9, k minus 3. All right, so now I've got all of these pieces, these 4 pieces broken down into their prime components, and now I can start canceling. Okay, so I've got the 3k minus 2's are gone, I've got the k's are gone, and I've got the k plus 9's are gone. So all that I have left is 4k plus 1 times k minus 3. Okay, that's this piece right here. Now I want to multiply that by this. Okay? So here I have a k squared minus 10k plus 24. And that has to be on the top, and then this one goes underneath. Okay? These are already broken down. Now that one can be broken down further. That's a trinomial. This is an easy trinomial, and this is an AC method trinomial. So again, we have work to do. So k squared minus 10k plus 24 is equal to, k is my variable. I've got a addition here, so that's the same sign, both negative, right? Two numbers that multiply to 24 and add to 10 would be 6 times 4. Okay, so that's that one. Now I'm going to have to do another AC method on that. Okay, so I have 4k squared minus 15k minus 4. A times c is 16. They have to subtract to a 15, so I'm going to want to use the 16 times 1 combo. So I've got 4k squared minus 16k plus k minus 4. Remember, these two have to recombine to that one. That's the only way that they do. Group, 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 front and back. I've got a 4k that's in common here. Dividing through by 4k, dividing through by 4k. This gives me a k minus 4, right? That's 4. These two have nothing in common but a 1. Right? And now these two have the k minus 4 in common. What's left is the 4k plus 1. K minus 4, 4k plus 1. Where do I put that? Have I lost my way? I think I've lost my way. Dang it. Where am I? I don't think I wrote that one down already. So we have 4k plus 1. That's that one. Then we have k minus 3. That's that one. Then we have this one, which is, where is that? Oh, it's right here. Right? So now we have, I was looking for that, but couldn't find it there for a second. What a mess! K minus 6, k minus 4, that's that one factored. And that all has to be over this one factored, which is down here, 3k minus 2. (4k plus 1). Now we cancel. Can't cancel much. That's it. So you've got this times this times this divided by that. Okay? All right, so that's how we do these harder problems. We just factor and cancel. These are kind of a nightmare just because there's a lot of room for error in here. You know, just doing, you know, one of these little pieces wrong is really common. I probably do that all the time. I know I do that all the time. So, and I might have done it in here. I didn't check the answer. So if I did something wrong, just make adjustments for it and keep going. So anyway, that's 7.1. So we'll get together again for 7.2 and see what's left in there. And I'm pretty sure it's adding and subtracting. And we will be done then. All right. So I'll see you for 7.2.